This meeting is being recorded.
In this next problem, we are given some information regarding specific types of reactions that have rearrangements, carbocation rearrangements, where shifts occur other than methyl groups. So carbon atoms can be rearranged in a way other than where we might be used to. So these methyl groups and hydride shifts that we've seen in the past are rearrangement problems that we looked at previously. But we're going to see here, when we have this alkene, this double bond attacked by our HBr here, we're going to have an addition reaction. So what we see here is that we're going to have a two-step arrow in this first, or two arrow in this first step of the mechanism, right? So we're asked here in part A to provide the curved arrows to complete the mechanism. So this is in conversion of compound 1 to compound 2. We will see protonation of the carbon-carbon double bond to form a tertiary carbocation. And either side of the double bond could be protonated to form a tertiary carbocation, but only this compound, compound 2 here, with this orientation would yield the rearrangement that we're referencing here. So this carbon here in compound 2 will rearrange. So the cation, the carbocation site, would then be down here. So right below compound 2, we see this rearrangement occur, and that's where we see compound 3 here that results. So at this point, we're going to have the bromide ion that was created in when compound 1 converted to compound 2, right? This bromide ion now will attack the carbocation and will form an alkyl bromide. So this right here will attack here, and that is compound 4 that we see. So that is part A of this problem, and then in part B, they ask us to, suggest a reason, rationalize why a tertiary carbocation may rearrange to form a secondary carbocation, since we know that tertiary is usually, the preferred form, the more stable carbocation over a secondary. Well, the reason behind this is that this involves something called ring expansion, and it's favorable because in compound 2, there's more ring strain. Right, so we have these bond angles in this like cyclobutane structure here in this four-membered carbon cyclic ring, and then that ring strain is relieved when we have this five-membered secondary carbocation, even though we originally could have thought that a tertiary was more stable. But because of that relief of ring strain, that is why, you should suggest a reason that this rearrangement is favorable.